Hello everyone, this is the 11th week class. What we are going to do today is to look at the output, right? Before we do that, I'm going to show you once again how to use Amos for the structural equation model, right? So I'm going to use this model once again. And let me show you how to use the Amos, right? So let me draw a graph first, and then I'm going to connect the graph to the data file, right? So in order to draw a graph, you need to click this one, right? And then you make a circle here, right? And we are going to click this one 4 times, since this latent variable is measured by 4 things, right? And again I make a circle here, and once again I'm going to click 4 times for the AC, and I'm going to make a circle here. Once again I'm going to click 4 times, right? And if you want to rotate, you click this one and you rotate these things, right? And then you draw an arrow by clicking this, and this one goes to here and this one goes to here, right? And if there is a correlation between the latent variables, and you click this one and you connect these latent variables, right? If you want to change the direction, you click this one and you change the direction, right? And don't forget to put errors for the dependent variables, right? So in this case, this one, right? This latent variable is a dependent variable, right? Because error comes in, right? So in this case, you need to add errors, right? By clicking this. So I'm going to add error here, right? Once you have done that, you are going to connect this graph to the data file, right? So you click this one and you click data file and the file name, okay? And I'm going to use EPACOC, right? And all right, so you're going to click OK, right? Once you connected this graph to data file, in order to put names, you click this one, right? And you will have variable names, right? So you are going to drag these things right? So you drag the these variable names to the box, right? And then you need to name the latent variables and errors, right? So let's close this, and I'm going to double click this one, and I'm going to name this one as AC, right? And I'm going to name this one as EP, right? And also I'm going to name this one as OC, right? Right? And also I'm going to name this one as E1 and this one as E2 and this one as E3, right? And this one as E4, right? And I'm going to name this one as E5, right? And this one as E6, and this one E7, and this one E8, right? And this one E9, now, let me talk about these ones. Suppose you wanna make variance of a specific error is equal to 0, right? Now, suppose you wanna make, this one, the variance of E1 is equal to 0, right? Then you click this one, right? And then you check the parameters, right? And then you can put the value here, right? Right? So if you have only one indicator variable, right? You need to make the variance of that indicator variable set to 0, right? So in that case, by selecting parameters here, right? You can put zeros here, right? Now, once you name, these things, and then you go to the view, and you select analysis properties, right? And you choose the method here, and you click the output here, and you check standardized estimates, right? And whatever you want, right? And I'll talk about this one later, modification indices, right? And once you check these things and you close this, and then you go to the analyze, and you select calculate estimates, right? And name the file. So this is a test. Okay, so if you want to look at the output, you go here and you select this one, right? So this one is the first page, and then you go to the estimates, right? You get the regression rates and standardized regression weights, right? And if you want to look at the model fit, right? You see here C mean and GFI and RMR. So today we are going to talk about these things, right? Now let's try to understand these outputs, right? So this is the first page of the output. It shows the number of parameters and the chi-square and those things, right? And the important page is this, right? So this one is basically shows the coefficient values, right? So for example, there are two types of coefficient values. One is regular coefficients, and the other one is standardized regression rates, right? Actually, either one is fine, but usually you use the standardized weights because it also shows the strength of the relationship, right? So, for example, in this case, EP to OC is the plus 0.452, right? And also you have coefficient for the relationship between AC and OC, right? In this case is a 0.189, right? By comparing, these numbers, right, the relationship between EP and OC is stronger than the relationship between AC and OC, right? You can use these ones also as a coefficient, right? Also, in this case, the important thing is to the hypothesis here, right? So you have a p-values here, right? This one is p-value for some type of hypothesis, right? So in this case, so remember that we had EP, AC, OC, right? So this goes to here and this goes to here, right? So you want to test, this is the, let's say this is the coefficient P1. And this one is coefficient P2, right? So you want to test whether P1 is equal to 0. P1 is not equal to 0, right? If P1 is equal to 0, that means what? There is no relationship between EP and OC, right? So in order to test this, you use the p-value here, right? This one says almost 0, right? So these ones, almost 0, right? So almost 0 means p-value is almost 0, right? So this is less than alpha. Let's say alpha is 0.05, right? So you reject the hypothesis, right? In this case. So that means the relationship between EP and OC is meaningful, right? And also you see the sign here is a positive, right? So there is a positive relationship between EP and OC, right? Right? Same for the relationship between AC and OC, right? So in this case, you are testing P2 is equal to 0, right? P2 is not equal to 0, okay? So in this case, p-value is what? In this case, 0.03, right? P-value is 0.03, right? Still, this one is less than alpha if alpha is 0.05, right? So you reject the hypothesis, right? However, if your alpha is 0.01, right? If alpha is 0.01, then the 0.03 is greater than 0.01, right? So you cannot reject in this case, right? cannot reject null hypothesis, right? So it depends on the alpha value, right? So if you want to support the relationship between AC and OC, then you have to set alpha is equal to 0.05, right? Then you reject null hypothesis. That means there is a meaningful relationship between AC and OC, right? Let me repeat this thing. These p-values are used for hypothesis testing, right? So the first one, as I said, the star is almost 0, right? So that means you reject null hypothesis. In this case, null hypothesis is, as I said, P1 is equal to 0, right? The relationship between EP and OC, right? So you rejecting null hypothesis means there is a meaningful relationship between EP and OC, right? So let me write again here. So in this case, null hypothesis is P1 is equal to 0. Alternative is P1 is not equal to 0. Okay, in this case, almost 0, right? P value is equal to 0. That means this one is equal to 0, right? Either one is fine. Alpha is 0.01, all right? So reject null hypothesis, right? Now this one, okay? This one is P2 is not equal to 0. Right? So p value is 0.03. That means what? So this one is if alpha is 0.05, right? You reject the hypothesis. Okay. But alpha is 0.01, then is greater than 0.01, right? So in this case, reject null hypothesis. Cannot reject. Null hypothesis, right? So this is critical part, right? Now, what is CR? CR is is called the critical ratio. It's the same as T value, right? It's T. So if you don't have a P value, then you can use a T instead of P value, right? When you use a T, you compare T value to 2, right? So if T value is greater than 2, you reject null hypothesis, right? 2 is like when you have alpha is 0.05, right? Now that's the relationship between independent variable and the dependent variable, right? And when you want to compare the strength of the relationship, you use standardized regression rates. Okay. Let me to clarify this, EP, AC, OC. Okay, this one is P1 and this one is P2. I mean the coefficients, right? Now let's go to the goodness of witness index, right here. There are lots of measures here. As far as I know, different fields use different measures, right? But usually these ones are the frequently used: C mean, GFI, and RMR, right? These things. Basically, C mean is the chi-square value, right? Chi-square. C mean stands for the minimum of C. C is a kind of it's a number. right? So C is not the words, right? It's kind of it's a value, right? So anyway, C mean is chi-square value, right? In this case, there is a p-value for this. By the way, you only concerned with the default model, right? You don't need to look at the saturated model, independence model, right? You only look at the default model, and P, since you have P, right? There is a hypothesis testing going on here, right? So what is the hypothesis in this case? Basically, chi-square is like this. Sum of theoretical observed minus theoretical square. Okay, chi-square is computed by using this formula. So it's a sum of some kind of a fraction, right? Here in the denominator you have a theoretical part. In the numerator you have square of observed minus theoretical, right? So it's if high chi-square means what? High chi-square means you have a big numerator, right? Big numerator means what? There is a quite a big difference between observed and the theoretical, right? That means what? It's not good, right? So your model is not good, right? Let me explain this one again. High chi-square means what? You have a big numerator, right? Numerator. Big numerator means you see a big difference between observed and the theoretical, right? So that means your model is not good. Okay. Actually, the null hypothesis observed is equal to theoretical. Retical. Not equal, right? So in this case, in order to have a good model, right, you should not reject null hypothesis in this case, right? Okay. So that means if p-value is, in this case, p-value is pretty high, right? If p-value is less than alpha, right, then you reject null hypothesis, right? In this case, since p-value 0.975 is greater than alpha, right? Okay, that's good news. Why is that? Because you cannot reject, right? Can't reject null hypothesis. All right. Let me explain this one again. From this output, so C mean is one of the measures that we use. Basically, C mean is the chi-square value. Okay. C mean stands for minimum of C value, right? So C is not the word. C is a kind of value, right? And C mean is equal to chi-square. All right. Chi-square is computed like this, right? So you make sure that your theoretical matrix is as close as possible to observed, right? In order to make sure that your model is good, right? So if you have a big chi-square, high chi-square, it's bad news. Why is that? Because chi-square is big means what? There is a big difference between observed and the theoretical part, right? From the formula, right? You see? So smaller chi-square is better, right? And in terms of the p-value, if p-value is less than alpha, then you reject null hypothesis, right? That's bad news. Why is that? Because in the null hypothesis, you see the observed matrix is equal to theoretical, right? You don't want to reject this one, right? So high p-value is good news. Why is that? Because you cannot reject null hypothesis. Okay? So that's the C mean, right? And GFI is goodness of fit index, right? This is kind of R square in regression, right? Remember that R square is explained variation over total variation, right? So high R square means what? It's good, right? GFI is same as R square, right? So in this case, it's a 0.965 means you have a very good model, right? Since 96% of total variation is explained by your model, right? And also the RMR is residual. Okay, residual is what? It's observed minus theoretical. Okay, residual is the is equal to observed minus theoretical, right? If you have a small residual, means what? It's your model is good, right? Because there is no big difference between observed and theoretical, right? Small residual is good, right? So small RMR is good. Okay. We examined some of these measures, but there are lots of other measures, right? As far as I know, different fields, right, prefer different measures, right? But these ones, the C-mean and the GFI and RMR, are the common measures used in lots of areas, right? So that's the output for the Amos, right? So let's stop here.